scientific integrity of the film, to make sure that it's very, very close in reality, but still we want to make certain that it has a base of reality.
Before the end of the 60s, we will see a man to the moon, an American, and we're very proud that our country continues to produce.
We've been brought in here by Stanley.
That an aggressor nation that dominates space will then dominate the world.
We're in the final assembly building of the LEM. Stanley Kubrick and I have set ourselves several objectives. We hope to convey to the public the wonder and beauty and promise of the new age of exploration which is opening up before the human race.
Arthur, here we are on the LEM ship, and one can almost imagine we're on our way to the moon, or we've arrived at the moon, as a matter of fact.
Can you believe it? Can you realize that you and I, that all of us, have actually begun the exploration of another world? We have taken the first
That an aggressor...
On the surface of the moon this morning, and the suspense here in London is unbelievable.
Hello, Apollo 11, Houston. Okay, Neil, we can see you coming down the ladder now. Okay, Neil, we can see you coming. Yeah, I'm going to step off the LEM now. Neil and Buzz, the President of the United States is in his office now and would like to say a few words to you, over. That would be an honor. Go ahead, Mr. President. This is Houston out.
Hello, Neil and Buzz. I'm talking to you by telephone from the Oval Room at the White House. And this certainly has to be the most historic telephone call ever made in the whole history of man. All the people on this earth are truly one.
That's the best. Let's say it's another one to print. I think that's awfully good. That one and the one before it was pretty good.
Do we have about 15 seconds?
Oh yeah, you got a lot of time.
Yeah. I claim this land in the name of...
What do you got now? Now move.
Cut it.
He needs to go off this mark.
Once more, please.
Otherwise, he, let me walk it. Back in the middle of it. Headlight.
One thing I really want your generation to embrace is that the Earth is a closed system. We cannot leave the Earth. There's no place to go. There's no place to throw your trash.
Why has nobody been to the moon in such a long time?
That's not an 8-year-old's question. That's my question. I want to know, but I think I know. Because we didn't go there. Because we didn't go there. And that's the way it happened. And if it didn't happen, it's nice to know why it didn't happen. So in the future, if we want to keep doing something, we need to know why something stopped in the past if we wanted to keep it going. Money.
When you looked up at the sky, could you actually see the stars and the solar corona in spite of the glare?
We were never able to see stars from the lunar surface or on the daylight side of the moon by eye without looking through the optics. I don't recall during the period of time that we were photographing the solar corona what stars we could see.
I can't imagine that he was debriefed and that kind of question wasn't asked. What he saw, what he felt, what he experienced while on the moon. And now listen to Mike Collins, who was sitting to the left of Neil Armstrong.
I don't remember seeing any. Neil, you were a little bit concerned, you said about...
So now Mike doesn't remember seeing any stars either. We have to remember that the reporter asked about them looking up at the sky and if they could see the stars based on the circumstances. So Mike Collins' answer has got to apply to his experience in the command module itself because he didn't walk on the moon or go down to its surface. But let's look again at Neil's response to what Mike said.
I don't remember seeing any. Neil, you were a little bit concerned, you said about...
Notice his body language. And it looks like Neil even whispers something under his breath to Mike. Was he telling him to simply shut up? I don't know, but the interaction looks really odd to me. All right, here is another interview with Neil Armstrong. And right after I show you this quick piece, I'll immediately share a few more statements made by other astronauts who shared what they could or couldn't see while in outer space.
Mr. Armstrong, I do realize that when you were on the moon, you had very little time for gazing upwards. But could you tell us something about what the sky actually looks like from the moon, the sun, the earth, the stars, if any, and so on?
The sky is a deep black when viewed from the moon, as it is when viewed from cislunar space, the space between the Earth and the moon. The Earth is the only visible object other than the sun that can be seen, although there have been some reports of seeing planets. I myself did not see planets from the surface, but I suspect they might be visible.
Whilst
from
in
Mark
space,
Cameron. This is from Mark Cameron.
Whilst in space, have you ever looked away from Earth into the black void?
So because you can see, so you can see the stars.
Oh yeah.
You know, and pretty much all the time you can see the stars.
The sky is a deep black when viewed from the moon, as it is when viewed from cislunar space, the space between the Earth and the moon.
Space, and you're on the sun side of the orbit. The sunlight washes out all the starlight, so you can't see any stars, just like here on Earth.
There's all the stars there, and the cool thing is about it, you can see it during the day.
Yeah, you can, and there's more than stars. You can see planets. You can see moons.
You see the gas Magellan clouds of the Milky
you
Way
see
galaxy.
The Magellan.
Pretty much all the time you can see the stars.
Then when you look out into deep space away from the sun, it's the darkest black you can imagine.
So this black space you're looking at on your screen right now could or couldn't be what you see when viewing outer space from outer space. I guess you have to go to outer space or walk on the moon to confirm this truth for yourself.
Over the years, I made several videos regarding so-called astronaut Don Pettit, basically the head of mockery when it comes to NASA. I find it very interesting what he says during this interview from a few months back. He basically states that technology to go back to the moon has been destroyed. He'd love to go back in a nanosecond, but that technology does not exist anymore. But then he goes on to talk about going to Mars. Okay, first off, before even showing this video clip with him speaking about, again, this technology, which I find very bizarre, saying it's been destroyed. How was it destroyed? He doesn't go into details how this so-called technology that they used to go to the moon years ago has been destroyed. Let's take a look, first off, again, when it comes to mockery in this video clip. Basically, again, mocking his audience, his followers, during this presentation. Take a listen to what he says here.
Astronauts are really, really good at making pictures in space that look like you've never left the planet. In fact, it's almost hard-pressed to tell whether you're in space or not in this picture. You know, we've got some fancy backdrops, I guess.
What a strange person this is. You know, basically, again, if you follow my channel and see my previous videos on this so-called astronaut Don Pettit, of course, none of these men have been in space. They're nothing more than basically actors playing a role on the world stage, making the masses, the millions upon millions of people throughout the world believe they've been in space when they've never been in space at all. Now I'm going to play the video clip itself with Don Pettit again being interviewed. Just very bizarre interview. Not going into details how this so-called technology to go to the moon has been destroyed. And at the very end, I'll point out something very interesting what he says. People need to read between the lines. Take a listen.
I'd go to the moon in a nanosecond. The problem is we don't have the technology to do that anymore. We used to, but we destroyed that technology, and it's a painful process to build it back again. But going to Mars should be one of the next series of steps that humans do. The first step should be going back to the moon for a number of technical reasons and exploration reasons, and then after that, Mars, maybe high orbit in Venus atmosphere, maybe going to Europa. There's all kinds of targets to go to, places of interest in our solar system. The only limit to human future is in our own imaginations.
And with that goofy look on his face, he states the only limit to human future is our own imagination. So I find it very interesting. He's not saying it's based on technology, what's feasible based off technology. He says it's based on our imaginations. So when it comes down to it, like I played this video clip I'll show in a second with William Shatner stating, science and science fiction are one and the same. There's no difference whatsoever. Take a listen.
My question is, through your career and your writing and your acting, you've inspired so many people to enter the sciences. How do you balance science with science fiction?
They're both the same. The mystery of science fiction is what I'm talking about. Science and science fiction are essentially the same.
Thank you very much.
How do you prove a black hole? How do you know those gravitational waves proved the collision of two black holes?
Somehow, eventually, they are able to observe phenomena.
No, they can't observe. It's too far away. It's too theoretical. How do we know what they're saying is true? You know what it really is? It's all science fiction.
Science and science fiction are essentially the same.
Thank you very much.
Because it started to get to me after a while.
What do you mean? What get?
I've always been conflicted about it, I guess, but I wasn't conscious of it until later, years later. You know, at first I was just blown away by the chance, the opportunity, the challenge of making this film, and I went into it like it was a regular film, like another production of mine, not thinking too much about the long-term effects, what it would mean to society if it was ever discovered.
Mm-hmm. What are you talking about? I don't even know what you're talking about. You're referring to something.
The moon, the fake moon landing.
The rumor about the fake moon landing. You're saying is not a rumor or not is not an urban legend. You're saying it's true.
Yes, I'm sorry. I thought you knew that. But
no, I didn't. I mean, I've heard it like anyone else has heard it, but you.
Okay. Yeah, it was fake.
Wait, okay. And I thought, okay, I have written down, and I thought you agreed to talk about Barry Lyndon. You agreed to talk about The Killing, Clockwork Orange. I mean, we're going to cover all these films, and I hope we still can. But what you're telling me is this? Because I've never. I think it would make the news if you're telling me now for the first time. And why me? Why not CNN or?
What? The rumors were true.
Okay. Okay, well, I obviously want to understand what the hell what you're talking about here. Okay, but why are you telling me? I'm a nobody.
The moon landings were fake.
Okay, and I want to hear what the hell. I'm sorry, what the hell you're. I don't know. Tell me how, what, when, where. I'd like to hear the story about this, but why are you telling me? And is that so? That's the 15-year thing. So that makes sense now. That's why I can't release this for 15 years. That makes total sense now.
Yes. And my upcoming film, Eyes Wide Shut, is all about secrecy. It takes place in the sexual underground, but it's really about secrecy.
Okay, well, before we even talk about the meta of secrecy, like what the F's are like, wait, Start from the beginning here. Can you start from the beginning? Like,
secrecy.
okay, but let's take it back to the beginning. That we didn't land on the moon. You're saying, and you filmed.
No, we didn't land on the moon.
Okay, so I was born in '71.
nobody landed.
I was born in '71. I didn't see that stuff anyway. So just how about you walk me through it? If you have, just indulge me here. We'll just do it quickly, or as quickly as we can. How did something like this start? Does someone do you apply to an ad to film the moon landings?
No,
like what?
I was contacted by NASA.
Okay, when, where, why? I mean, what happened?
Before I started making 2001, so in the mid '60s sometime.
After Kennedy said his thing, you're saying?
Well, considerably after then, yeah. And they had seen Dr. Strangelove, and I had originally requested use of the B-52 to film part of Dr. Strangelove, and they refused. But they were very impressed by the final.
It was a great film. I mean, great film.
It's one of my personal favorites. Yes,
Yeah.
they were very impressed by the look of
But
it.
they wouldn't let you use a B-52 that you asked for, right? You asked
No,
to
they
do
would
it.
not.
Why not? I mean, well then, so you have on Rocky. Was it Rocky?
It's just force of habit. I think they're just very secretive.
Okay, and
Keeping in with the theme of.
But yeah, even though they denied you there, you're saying, well, what? So when you're doing 2001, obviously that's the space movie. So you're saying when you're doing the space movie, they contacted you then? I mean, obviously there's a relationship between that.
Yes, that's right.
Okay, so what happened?
And they were planning this fake moon landing. They wanted.
But why did they have to fake it? Why?
Because it is impossible to get to the moon. If you ask any scientist, we couldn't do it. Okay. There's the Van Allen belt, which is it's impossible to get past.
Okay.
If you think of our space program and how many trips we have made since the alleged moon landing,
right?
They stopped in 1972. What sense does that even make? That if we went there, 3 or 4 times between 69 and 72, and haven't gone since, nor has anyone else, not even the Russians. It's a little bit of a stretch of the imagination to think that we did. Why would we not go?
Or no other country.
Because it's impossible to go. The furthest anyone has ever been off this planet is about 400 miles.
Wow.
The moon is several hundred.
It's a quarter million.
Yes, miles away. It's just not possible. It wasn't possible in 1969, and it's not possible now. Anyway, he complimented me on 2001, and then he said, speaking of space, you know about President Kennedy's prediction of going to the moon by the end of the decade.
Well, it was almost like a mandate. Like he sort of like, threw the gauntlet down.
And he said, well, time is running out, and we want to do that, but we can't. It's impossible. We tried. We've been testing this for years. As you may have heard, there was a launch pad accident in 1967 in which the famous Gus Grissom was killed and 2 other astronauts. Gus was a good guy, but anyway, and it can't be done. We talked to every scientist imaginable. It just cannot be done. But after seeing your film, I am convinced, and the gentlemen at NASA are also convinced, that you can help us make people believe that we have been to the moon and back.
And you must have been startled at that moment. Okay.
Actually, a little bit, but I also knew where this was going, and I thought, what a trip. What a trip this is for me, as an artist.
Okay, you were still young and wide-eyed.
I couldn't help it.
Okay.
It's part of being, it's like it's the DNA or something of an artist.
Like your adrenaline got going.
Yes.
Your juice is flowing. Okay.
Yeah.
Go on.
And I was excited.
All right,
He
go
didn't
on.
even have to finish, but he did. And explained to me that he wanted me to film a fake landing with fake astronauts. Well, not real astronauts, but faking the exploration of space.
Because they just knew they couldn't get there.
Because there was just no way we could get there.
And the political, I mean, they'd spent all that money, I guess. And
yes.
There was a political brinksmanship going on.
Of course, Nixon wanted to make a big splash. It was early in his presidency.
Yeah, that would have made him look really like a failure.
He wanted to. He wanted his approval points up, and he thought nothing could do it better than this, to fulfill this dream that America has had as a country since the Kennedy years.
Okay, so you're saying the motivation was PR.
PR, absolutely, plain simple, PR.
All right, and the geopolitical chess match between Russia that was going on, it would have weakened their position, so to speak.
Yes.
And I guess
that
money.
Was background. That was a great background for the story. Yes.
But also, it must have been about
because there was still
money.
A red fear, a communist fear among the people.
Right. Sure, that was right. You're kind of yeah. Sure. I mean, missile crisis and all that. Okay, but it's also really about like anything else about money. I mean, they'd spent the equivalent of $1 billion, almost $1 trillion of our dollars now on this program.
Yes. In addition to being impossible and unsafe, it was also terribly expensive.
But what I'm saying is that it was so expensive that to fail would not, quote unquote, not be an option. In other words, at a certain point, you spend so much taxpayer money. My question I'm asking is Nixon motivated, whoever these men that decided this to perpetrate this fraud, was it the money? In other words, if you can't go to or maybe you can, I don't know. Can you go to the American people after spending $1 trillion and say, we've got nothing to show for it?
No.
So
obviously.
But I'm saying is how much of that was the motivation?
Of course, that was a huge part of it. A huge part of it.
It's the part, really. Again, so many people, and the funding would have dried up. You have to go with that because that's going to be the whole Neil thing. That's why Neil goes along with it, because Neil doesn't want the program to die.
Right.
Okay. So it's the money. It's the right. It's the PR politics. It's Russia, and it's the money. Okay.
Yes.
So it's balls and so it's already. So what did Nixon say at the very end? He looked me in the eye. Give me the clothes. Okay. So. And give me some color, like some things happening. So he sat down and he sighed. Looked into the fireplace. Give me some details.
All right.
So he said all that, and then what?
I think this was hard for him to get out. This next part, but he said the NASA's funds are just drying up.
They can't fund something that doesn't work.
Yes.
If we don't fake it, if we tell them the truth, the money goes away, and we think we're this close.
Yes.
So we have to lie. It's a good lie. It's a lie for a good reason. We're this close.
Yes.
But they never got closer. So it was even in earnest, maybe, perhaps. Got it? So Nixon says
it was hard for him to say this next part. He was. Looking into his drink kind of like I am now. And finally he said that we can't tell people the truth, that we can't get to the moon. It would be disastrous for NASA. Their funding would dry up. People wouldn't have faith in them anymore. It would be like
faith, it would be over,
failure.
Right? It would be over.
Yes, it would be absolutely over. So if we fake this moon landing, it would do nothing but increase the reputation, and we could go again and again if we had to.
Just to go the first time. So they wanted to keep the funding going. Why? Because.
Well, obviously. What do you mean?
Why they wanted to lie about the moon landing to keep the funding going. Why?
Just to keep NASA viable.
Why though? Why?
Why not? Because people believe in NASA.
No, because they thought that the moon landing was just a few more years. That if they would get there, they just kept the funding going. They could get there. They could figure the problems out, but they never did. That's the point. It's not arbitrary. We want to keep NASA alive because it's the dream, and we knew they lied.
You're saying NASA's believed they still could.
At the time, and then, you know, finally it hit them probably by 75, we're fucking never getting there.
All right, okay.
That's the sympathetic reason why they did this. And you're like, wow, that makes sense, but it's still wrong. Get it?
Okay, yeah.
So that's a big thing. I said this to you, let's try again, ready? So Nixon says what?
He you know, looked at his drink kind of like this and said, we have to fake this. We have to fake this moon landing, just to keep interest in NASA, and in the next few years, we might actually be able to go for real.
Come on.
We wouldn't give up. We'd still work on it. We would still be working on it, trying to make this trip possible. But we have to do it now.
No, because they were so close, you know.
Because we were so damn close. We had to do it now.
And if you didn't lie, you know, it would dry up. We were on the brink of something.
Yes, and if we didn't fake this, if we didn't lie about it, eventually people would lose interest, and the funding would dry up for NASA. It would just cease to exist.
And the dream.
And the dream would be dead. It would be gone. The greatest thing in the world for this country would be to go to the moon, and that being gone, it would be just devastating for the national mood.
So about money,
and
about
yeah, and
so, no, yeah. I'm just giving you lines. So it was about the money. It was about the morale.
Yeah, it was about morale. It was about money. It was about money. It was about morale, chiefly money, as most things are, and that's what was.
But we're going to explore tonight a little bit about the myths of science. We're going to challenge specifically the myths of astronomy. Now, many of you know that one of my many hobbies, even as a kid, was astronomy. How many of you have had astronomy in your background as a hobby or whatever? Many. Okay, over half of you, sure. There was a time when I had money, a long time ago, I had a 14-inch celestron. I mean, I was serious about it. If you go up to Big Bear, you'll see that domed house that has it was like we took astronomy seriously. And I have to tell you, I'm startled to discover that most of what I've been taught in college, let alone in high school, isn't true. And that's what we want to look at. This gets to some other conjectures that you've all heard about, the idea of dark matter. The quote that you see in many articles, dark matter makes up about 26% of the universe. Really? The first hint of its existence came in 1933 when the astronomical observations and calculations of gravitational effects revealed that there must be more stuff present in the universe than telescopes could see. That's a widely held belief of many of our top scientists today. Why? I'll show you why in a minute. There's also dark energy. Dark energy makes up approximately 70% of the universe and appears to be associated with the vacuum in space. Well, there isn't a vacuum in space, but that's a whole other thing we'll get into. It is homogeneously distributed throughout the universe, not only in space, but also in time. In other words, the effect is not diluted as the universe expands. Really? These things are non sequiturs, and yet they're widely held among scientists. In fact, you should stand back, and it's humbling to realize that all that we know about matter comes from a 4% sample. There are books that tell you 96% of the mass of the universe is missing. How many have heard that somewhere? That's ridiculous, of course, it turns out, okay? And most of you are familiar that they're chasing some of these things with big dollars. The Large Hadron Collider in CERN in Europe. It spans the border between Switzerland and France near Geneva. It's 300 feet underground. It's the largest machine in the world, a circumference of 17 miles. It's the fastest racetrack in the world. Trillions of protons traveling at almost the speed of light, guided by 9,300 magnets. We spent a lot of money here. 600 million collisions each second, and we could go on and on about this thing. Okay, enough of all of this. Let's zero right in on the myths of the present. One of the statements that you see is there is a black hole in the center of that galaxy. Why do they say that? Well, if there wasn't, they can't explain its level of energy output. That's a conjecture to try to explain something they can't explain. There is invisible dark matter in that galaxy. Why do they say that? Because otherwise they cannot explain why it rotates the way it does. the way the galaxies rotate imply that there's not enough mass there to cause that to happen gravitationally, so there must be mass that we can't see. That's why they call it dark matter. Okay. Another statement you see in the current, I'm talking about current reports in your literature. 96% of the universe is made up of dark energy and dark matter that we cannot see. Really? That all we know about mass comes from a 4% sample? You got to be kidding. Otherwise, clusters of galaxies would fly apart because gravity alone can't hold them together. Really? Then maybe something other than gravity is operative here. Pulsars are made up of strange matter. That's another statement you see if you start reading in pulsars. Otherwise, they can't explain their oscillator-type behavior. But here's the fun one. Photographs of connections between two astronomical objects that have different red shifts are only chance alignments. Red shifts are supposed to be measuring the expansion of the universe. They have some things that are so close together, they're apparently associated, and yet they have different red shifts. That's embarrassing. How do they explain that? See, if they're only chance alignments, otherwise the Big Bang is being falsified, the whole Big Bang theory. Halton Arp was Edwin Hubble's assistant, a long-time observer at Mount Palomar and also Mount Wilson. His photographs contradict the whole concept of the Big Bang. And so he's not allowed to publish in most of the technical journals because they don't agree with his obvious conclusions. So I want to talk a little bit before I go further on what I call Epistemology 101. Epistemology, study of the origin, scope, and limits of knowledge. We take pride in a methodology we call the scientific method. How many have heard of the scientific method? The other name for that, more properly, is called the empirical method. What is the scientific method? If I gave you a written quiz, I imagine a few of you could pass, because here's what that really means. Step one, you observe a phenomenon. Step two, you seek patterns and measures in that observation. Step three, you formulate a hypothesis from that description. And then the fourth step is you gather independent data to challenge that hypothesis. It's that simple, and yet it'll shock you to discover that it's rarely practiced in certain fields of science because they can't repeat the experiments that they're trying to explore. See, the search in scientific method is a search for failures, not successes. Theories can never be proven. Did you know that? That comes as a shock unless you've studied this field of study. That theories can never be totally proven. What they can do is defy being disproven, but they're never fully proven. They just they develop a reputation for being difficult to disprove. There's a big difference there, a profound difference there. When you study information sciences, Shannon calls what he calls verifiability the definition of meaning. Something that can't be verified is defined in information sciences as meaningless. If you can't verify it, it's a meaningless statement. For example, if I suggested to you that before this talk is over, all clocks in the world are going to slow down by 10 seconds. Well, if all clocks in the world slow down by 10 seconds, there's no way to prove that. That's what we call a non-verifiable statement, which means it's meaningless. See, it only has meaning to the extent it can be verified. Untestable statements are defined as meaningless. We need to grasp that. It's important. The great tragedy, according to Huxley, the great tragedy of science is the slaying of a beautiful hypothesis by an ugly fact. Non-falsifiable hypotheses are non-scientific, and by the way, they're intellectually dishonest. And yet we'll discover our lives are full of those. In logic, there's a classic error in logic. It's called argumentum ad ignorantiam, and it's an argument from ignorance. The assertion that something must be true simply because it hasn't proved false is an error in logic. Just because it hasn't been proved false doesn't make it true. You need to understand that. It's fundamental in our thinking. Well, since the scientific method is really not available in certain fields of science, archaeology, geology, there's a number of places where you're studying something, you can't get a repeatable type of situation, so you go to alternatives. What are the inadequate substitutes for the scientific method? The first is the deductive method. That's where you derive theories by generalizations about the universe. They may be useful, but they're not necessarily true because they haven't been verified. Another alternative, and this is the one that we've all been injured by, mathematical proofs. Elegant consistencies that occur within a synthetic universe, a man-made, and mathematics is a synthetic universe. Mathematics is a collection of symbols and rules that create a synthetic universe. It doesn't necessarily bear relevance to reality. That may shock you. Elegant consistencies within a synthetic universe, models don't necessarily, models are not reality, no matter how elegant they are. You've got guys like Stephen Hawking and a number of these other mathematicians, they're absolutely brilliant. And they explore and dive into subtleties of these incredibly elegant, complex mathematical models. That doesn't make them correct. It doesn't mean they have anything to do with reality. That is yet to be demonstrated. And so there's another source of error. That even equations that prove to be correct may be correct only within certain domains of validity. What you know about the weak and strong nuclear forces have nothing to do with gravity. They're true with what happens within the atom in very small distances. What happens in gravity is quite different. Well, we're going to see quite different what happens in the galaxies. I'm going to demonstrate that to you in a minute. The illusion of knowledge, the only one certain barrier to truth, is the conviction that you already have it. You know, our trademark Bible verse for over 40 years has been Acts 17:11. Be like the Bereans, in that they received the word of God with all readiness of mind, but searched the scriptures daily to prove whether those things be so. The difficult part of that policy isn't searching the scriptures daily. The difficult part is having an open mind. Because we're all victims of our presuppositions. We need to guard against that and recognize that. Fortunately, the greatest obstacle to discovery is not ignorance, it's the illusion of knowledge. The belief you already have the truth. Now, let's talk a little bit of the milestones of influence throughout, Johannes Kepler in the 16th century, he discovered that planets are in elliptical orbits with sun at one of the foci, that the sun's radius vector sweeps equal areas in equal times, and that the planets' squares of the periods are to each other as the cubes of their mean distances. Now that, in his day, was a profound advance in understanding that explained the motions of the planets in the solar system. And that was, it was within a decade later that another guy was born by the name of Sir Isaac Newton. And he carried that principle of Kepler substantially. He established the basis of classical mechanics, advances in optics, differential and integral calculus, and he was a serious Christian, by the way. That's the other thing interesting about these early founders. You may not know that Sir Isaac Newton wrote over a million words on Daniel and Revelation. I have the copies. It's interesting reading. He wrote on hermeneutics. But he's most well known, and he changed the world with his, what's known as the inverse law of universal gravitation. And I want to talk about this because this one contribution of his changed the whole scientific landscape. And the inverse square law of the theory of universal gravitation. And what most astronomers fail to do is recognize that inverse square law aspect of that. This was his equation, that the gravitational force is equal to a constant having to do with units. It's the product of the masses divided by the square of the distance between them. And we'll talk a little bit more about G. It's not that important for us here. But I want you to remember this d squared underneath. In other words, you take the product of the two masses that are being attracted, and you divide by the square of the distance between them. That gives you Newton's law of gravitation. The whole field of astronomy is obsessed with gravity. but they failed to really understand that d squared thing, and I'll show you what I mean by that. Well, after Newton, we run into a guy by the name of Ben Franklin, 1706 to 1790. And while he did many things in his life, for our purposes tonight, there's one event had. The amazing thing was he wasn't electrocuted. He was stupid enough to fly a kite during a lightning storm. And he risked electrocution, but he determined that the sky was inherently electrical in nature. And the entire scientific community chose to ignore that. It's amazing that it took, several centuries for that to be realized in the scientific community. It's still just being recognized by the astronomers. I'll show you what I mean as we go. After Ben Franklin, we have a guy by the name of Michael Faraday, 1791 to 1867. He's the one that pioneered the concept of electromagnetic fields. In fact, Albert Einstein kept a photograph of Faraday on his study wall alongside Isaac Newton and James Clerk Maxwell. Faraday was highly religious. Here's another Christian, member of the Christian sect that demanded total faith and commitment. And even the biographer said he had a strong sense of unity of God and nature pervaded in his life and work. Boy, I hope they say that about all of us in our epitaph, if you will. Now we come to a guy that we're going to talk a little bit about tonight, because he's ignored by most people who get into, unless you either ignore him or you really get into him. Very few people in the middle. A guy by the name of James Clerk Maxwell. He codified the basis of all that we know about electrical science and engineering into a self-consistent set of equations. Originally 20, finally boiled down to 4, but all about electric currents, magnetic fields, that they intrinsically are connected. That magnetic fields, electric currents, magnetic fields are intrinsically involve a common behavior. And that electromagnetic energy propagates through space. So far, so good. Ranked with Sir Isaac Newton and Albert Einstein in the fundamental nature of his contributions in quantum theory, electromagnetics and electrostatics, thermodynamics, information theory, and cybernetics. Quite a guy, by the way. Okay? But along comes a guy by the name of William Thomson, who gets knighted, and he's known as Lord Kelvin. And from 1824 to the turn of the century, to 1907, he becomes an incredibly influential scientist in 1900 Great Britain. Lord Kelvin, profound influence. He was knighted for his work in thermodynamics. That's the good news. Let me give you the bad news. He was an outspoken critic and very pessimistic about the future of electricity and electromagnetic theory. He predicted that radio and wireless telegraphy had no future. Now, we laugh at that today, but he cast a pallor on that as far as the British scientific community is concerned. And as you study the history of science, you'll discover that from Kelvin on, the British Astronomical Society goes one way, and a whole other field of study is ignored by them that comes out of Norway, Sweden, and the northern latitudes. And that's what we're going to focus on tonight. But Kelvin was a cloud on this whole picture. And so I want you just to recognize the negative influence of this one man. Now, before we go any further, you need to have something else that I want you to do. I want us tonight, we want to have a way to somehow relate to extreme magnitudes. Scientists use fancy numbers to represent large magnitudes, but often they don't really understand that. I remember I was with Edward Teller and his sidekick Norris Keeler, and they were talking about 10 to the 17th something or other, and I said, gee, that's more than there are seconds in the history of the universe. They looked at me startled. What do you mean? Well, you're the guys that are going to try and tell me that the universe is about 15 billion years old. That's only 10 to the 17th seconds. They were startled. Just do the math. See, they used those numbers, but they didn't really have an appreciation of the science. We need to have an apprehension. Let me give you a new word that's in our vocabulary today to demonstrate what I'm talking about. We have a new word called trillion. How much is a trillion? I have yet to find a congressman or senator that can answer that question. Now, I'm serious. How much is a trillion? Okay. My old friend Bill Ruggles is here, And he and I got into some strange investments years ago. And if I said to Bill, I know I owe you some money, but I'm going to pay you back in 1,000,000 seconds. Bill would take out his calculator and 1,000,000 seconds, well, that's 12 days. I can live with that. Oh, I'm sorry, Bill, I misspoke. I'm going to pay you, 1,000,000 seconds, that's 12 days. I misspoke. I meant to say I'm going to pay you in 1,000,000,000 seconds. He gets his calculator out. How long is 1,000,000,000 seconds? 32 years. You see, that's not only a quantitative difference, that's a qualitative difference. He knows that ain't going to work. I said, oh, Bill, I'm sorry, I misspoke. I'm going to pay you back in 1,000,000,000,000 seconds. How much is that? 32,000 years. You see the point I'm trying to make? Million, billion, trillion. 12 days to 32 years to 32,000. Those are qualitatively different. We live in an economy with 14 trillion gross domestic product per year, carrying a debt of 800 trillion. Come on, what are you talking about? Check it out. It's important. Well, now let's get back to our subject at hand. How big is our galaxy? We can talk about all kinds of things and still not relate to how big the galaxy is, okay? There is a model suggested in the handbook of the Celestial Handbook by Burnham that's worth our consideration. It turns out it takes advantage of a coincidence. It turns out that the number of inches in a mile turns out to be about 63,300, give or take. The number of inches in a mile. It also turns out that in astronomy, a standard unit of measure is called an astronomical unit. It's the distance between the Earth and the Sun, okay? It turns out the number of astronomical units, which happen to be about 93 million miles, the number of astronomical units in a light year is the same number, almost. They're almost the same number. The number of inches in a mile and the number of astronomical units in a light year. That's going to be useful to us just to build a model, okay? The distance from the Sun to the Earth is called an astronomical unit. It happens to be 93 million miles. That's just a basic unit in astronomy. In Burnham's model, we're going to let 1 inch represent the distance from the Sun to the Earth, and we're going to let 1 mile represent a light year. You with me so far? Okay. Robert Burnham's handbook, Celestial Handbook's 3-volume standard stuff. Okay. Well, the Sun is 880,000 miles in diameter. In other words, on our model, it's about 0.009 inches. So our Sun, in our model we're going to build, represent a dot of a very sharp pencil. Call it like a period at the end of a sentence. That's going to be our Sun. You with me? Okay. So it's 1/100th of an inch, a tiny little speck. All the planets will turn out to be within a 7-foot circle diameter. The Mercury would be 4/10 of an inch away from that dot. Venus would be 7/10 an inch from that dot. The Earth, by definition, would be 1 inch. 1 inch being an astronomical unit. You with me so far? Okay. Mars would be about 1.6 inches. Jupiter about 5 inches. Saturn about 9.5 inches. Uranus about 19.2. Neptune 30 inches. Pluto would be 39.5 inches. Roughly a meter. So our whole model, if I was building the model of the solar system here, with the Sun being a little tiny period, the whole thing would occur within a 7-foot circle, 1 meter in radius, call it, okay? You with me so far? Now, the nearest star is a entity about the same size of our Sun that's 4.5 light years away, okay? If our nearest star is 4.5 light years away, I make a speck the size of the period. Here's the Sun over here. I've got the rest of it laid out 39.5 inches out here, right? I've got to make a representation of that star, Alpha Centauri, 4.5 light years away, which means it's 4.5 miles away. I suddenly have to get a larger piece of paper, okay? So 4.5 miles away. My question to you is, how much gravity do you think is operative between a speck the size of a period and another speck the size of a period 4.5 light years away when I have to square the distance between them? The answer is gravity has a negligible impact, right? If you imagine these two stars in the size of golf balls. One of them's here and the other one's in Denver. You get how much gravity is between two golf balls separated by almost 800 miles. You see what I'm getting at? So the Milky Way in our model would be 100,000 miles in diameter. See, you get a feeling of the vastness of these spaces. Now remember, in Newton's thing here, the square of the distances is the distances are squared, and they divide into that minimizes the impact. So we're going to explore a little bit what I call the boundaries of reality. And I'm going to use Da Vinci's Vitruvian Man as just a symbol of man's reach. And we're going to take size getting bigger to the right. So things that are larger than man, we call the macrocosm. And that leads to the study of astronomy and astrophysics. And the great discovery of 20th century science was that the universe is finite. It might be big, it might be expanding, but it's finite, not infinite. That has staggering implications. That's what led to the Big Bang conjectures and other things. Huge, huge. We're going to explore the other direction for even more bigger shocker things, the smallness, which we call the microcosm. Let's talk for just a moment about the model of an atom. We generally represent it by a nucleus and electrons spinning around it, right? Now, we know this is obviously not to scale. We know that the nucleus is in the neighborhood about 10 to the minus 13 centimeters. Okay, that's very small, but it's measurable, all right? The electrons moving around that are in the neighborhood of 10 to the minus 8 centimeters. What we're interested in here is the ratio between them, okay? The linear ratio between them would be 10 to the minus 8 divided by 10 to the minus 13, or 10 to the 5th. What I mean is that the orbit of the electron, if I want to visualize it that way, is 100,000 times the size of the nucleus, right? 10 to the 5th. You with me so far? But that's linear. If I'm laying this out in terms of area, I've got to square that. If I'm going to talk about volume, I've got to cube it. So the volumetric ratio is that thing cubed. Okay? 10 to the 5th cubed is 10 to the 15th. What does that mean? That means the amount of substance in the atom compared to the volume it takes is the same ratio as 1 second has to 30 million years. Let that sink in for a minute. I have a podium up here that feels pretty solid. Tim, our technician, would assure me that this is as solid as the technology can make it, right? And Bob Schober challenged that and says, no, there's nothing here at all. He's more correct than I am by a ratio of 1 second to 30 million years. This is mostly empty space. Why does it feel solid? Because the molecules that make up my hand are colliding with the molecules that make up this podium to create the illusion it's solid. And it's a very effective illusion, but it is an illusion. We are the victims of a digital simulation. Genesis chapter 1, and God said, let there be a firmament in the midst of the waters, and let it divide the waters from the waters. And God made the firmament which divided the waters which were under the firmament from the waters which were above the firmament, and it was so. There are two words that are translated here by the 1611 translators that need a little more reach. Rakia actually means an extended surface, expanse. It's labeled firmament in our English translation. It's an expanse, meaning it is a flat as a base or support. The Hebrew word signifies like a sheet spread or a curtain drawn out, is the thought. The other word there, that's mayim, which is translated waters, recognize that it's a term as close as they could get to suggesting fluids. Transitory things, fluids. And I'm going to suggest plasmas. That term was invented when we discovered what plasmas were. It also can mean danger or violence. It implies motion, if you will. So let me take a liberty here and use modern terms and translate those things. And God said, let there be an expanse in the midst of the plasmas, and let it divide the plasmas from the plasmas. And God made the expanse and divided the plasmas which were under the expanse from the plasmas which were above the expanse, and it was so. So I suggest that as a possibility. God challenges Job. He says, can thou bind the sweet influences of the Pleiades or loose the bands of Orion? These are constellations that are tied together, not by gravity, by electromagnetism. The seven sisters, the Pleiades, are a group of stars, but they're physically, they look like they're together. They're actually quite distant between them. What's binding them together is the equations of James Clerk Maxwell, not the equations of Sir Isaac Newton.